In this video, we're going to discuss the units of energy, and we're going to look at it in light of nutrition labels. So, well, there's arguably a lot of units of energy. There's really two that we're going to focus on. There is the SI, so Standards International Unit for Energy, which is the joule. The joule is kilograms meters squared per second squared. Basically, it's a mass that you move a distance at an acceleration. And so you can combine them. So pick up a weight and throw it. And so you move it some distance and you got it up to some speed from nothing. And so it has some energy involved. This is great for physics, but it's actually not the most common used for nutrition and even other things. And so common units are the calorie. So a calorie was actually based sort of on metric. The idea was it was the energy for 1 gram of water to go up 1 degree Celsius. So it was a heat component. It said, hey, there's some heat energy required to make a certain weight of water increase its temperature a certain amount. And metric liked to make everything about water, and 1 degree Celsius was handy, so this was where the calorie came from. Problem is that doesn't contain the standard units, the kilogram, the meters, the seconds, and so it was a little clunky, and the joule predominates for many things. Well, 1 calorie is equal to 4.184 joules. And so there's a relation between them. You can go between one and the other, but this is that ratio. Well, calories is useful for nutrition still. It is how we think of dietary labels. And if we go look at this label, we have, this was pulled off some beef jerky. So sample size, 28 grams. It has 90 calories. And it lists what's in it. It says total fat, 1.5 grams, minimal amounts of salt and cholesterol. And then carbohydrates, it has 8 grams, and protein, it has 11. Well, that 90 calories that it has for its energy, you'll notice it has a capital C. 1 capital C calorie is really 1,000 small c calories. Or effectively, 1 big C calorie is 1 kilocalorie. It's a kilo. It's a kilocalorie. So when you eat food, you're actually eating thousands of regular calories. We just use a big giant C to talk about, oh, it's a kilocalorie. So that's 90 kilocalories. That's 90,000 calories for a 28-gram piece of beef jerky. Where do they get that energy from? Well, there is only so much potential energy stored in bonds for organic molecules. And sugars, fats, proteins, they're fairly similar in construction and more or less average between all the different types of life. So we have some fairly good normal averages. 1 gram of protein is about 4 kcal in terms of energy. 1 gram of carbs, carbohydrates, sugars more or less, but starches and the like, is also about 4 kcal. Now, this is only good for about 1 sig fig. It's not an unreasonable value for the average. 1 gram of fat is about 9 kcal. So fat by weight has significantly more energy storage. This is part of why we really enjoy the taste of fats. Like whatever form it comes in, oils, lards, things like that, we generally really enjoy the taste of fats. Unless it's, a block of pure fat. The butter on its own isn't all that tasty. But spread over something else, it's very enjoyable in general. Our body likes the fact that we get a lot of energy for very little material. So we're evolved to be prone to enjoying fats. Well, I've got these average values, and I have the amounts of sugars and proteins that are in my food. These labels, we rarely actually burn and destroy a piece of food anymore. We really just test it to see how much protein there is, how much carbohydrates there are. Because if we wanted to calculate the calories from this, well, 1.5 grams of fat, and I know that in every 1 gram of fat, there's 9 kcal. So that's going to be about 13.5 kcal. That came from the fat. My 11 grams of protein at 1 gram of protein having 4 kcal should give us 44 kcals from my protein. And the 8 grams of carbs, for every 1 gram having 4 kcal, should be 32 kcal from my carbs. So if I want to add them up, this comes out 9, 1, 4, and 3. Comes out about 89.5 kcal, which to 1 sig fig is 90 kcal. Our dietary labels actually come from using these kind of generic averages most of the time. That's why they actually have quite a bit of variance. If you notice, your calories almost always end in a 0 on any label because they get around it. You can be off by 10% and still fall within FDA guidelines for things. And so most of your food is reasonably close to what it claims it has in it. But this is where it's actually coming from. And that's what the calorie actually represents. Which means that one piece of beef jerky with 90,000 calories, well, it could raise 1 gram of water 90,000 degrees, which would bring it above boiling. But what if you had 90,000 grams of water and you wanted to raise it 1 degree? Well, 90,000 grams is 90 kilograms. Hey, that's about my weight. I'm mostly water. So that one piece of beef jerky could raise my body temperature by about 1 degree Celsius, which is something we have to do. We have to keep ourselves warm. It doesn't do it instantly, or it bleeds it over time to keep me warm as I cool off from normal cooling. But we actually do burn plenty of food just to keep ourselves warm. Surprisingly, it doesn't take all that much. And so if we're well insulated, if we got good clothes and things, we really don't have to burn all that much food. But if you are out where it's cold, especially if you're having fun in the snow or everything, you tend to get kind of hungry afterwards. You might have been playing and having fun, but you also were burning a lot of food just to keep warm. That's why animals fatten up before winter and hibernate. It's not just needing energy to survive over time. They still need to regulate their temperature some. Even hibernating creatures tend to be above whatever the outside temperature is. And so we've got to burn some food to create that heat energy. And so this is the units that we expect to see. The joules and the calorie will mostly focus on the calories, but a little reference for where we see calories most commonly in society. We'll use it in various calculations later, but this is where we see it is usually nutrition facts. And so you can see if the labels kind of add up, or if you know what you're adding to your food, you actually have a reasonable idea what the content is. Did you make cookies? Well, if you put a cup of flour, so a couple 100 grams of flour, and a couple cups of sugar, well, those are all carbohydrates. So you might have had, well, let's say you made about a pound of cookies. So 454 grams. Well, that means 454 grams of carbs plus a little bit of butter. You're going to have 1,600 some calories plus some fat. Yeah, that pound of cookies you made is a good part of your daily intake. Most daily intakes are labeled at assuming 2,000 calories. And so we'll play more with calories and even a little with joules at one point. But this is the idea of units of energy. We're going to focus primarily on the calories.